but like different ways we're going to show it, because instead of a number line, we have a graph today. Okay, so first off, what are some of our inequalities? What's like one of the signs we use? Less than. Hang on to that for a second, Ruby. We're going to come back to that one. I'm going to start with the two basic ones that you learned like back in your first time doing math. We have less than and we have greater than. And then because Ruby was being an overachiever, she already mentioned the next one. What's the next one, Ruby? Yeah, less than or? Good, less than or equal to. And then what's our last one? Greater than or equal to. You might be like, I know this already. I know you know it, but remember we're adding on a little bit of information here. So take some time to rewrite that quick. Okay, come on, go so quick. All right, so for number line, that's less than or greater than. Yeah, get your notes out first. You got this written down? Yeah. Okay, just give her a second to get going, because otherwise you guys are going to just hang out and talk. You're not going to hang out and talk there? That's a lie. Give her 1 more minute, and then I'll let you go. All right, less than. How do I show less than on a graph? What's the difference like between less than and less than or equal to? Open and closed. Which one is open? Yeah, less than, it gets our open, which means you can see the inside of the circle. Less than or equal to gets a closed, which means we shade it in. What about greater than? Open. Just like you're going to miss like one of the most important parts, just like 45 more seconds. All right, and then greater than or equal to will be closed. So on a graph, when we do our boundary is written as a line. And as a line, we need to show that a line is either open or the line is closed. So a closed line, not a clothesline, closed line, is going to be a nice solid line. It looks like our normal line. That's closed. If you want to write solid next to it, that way sometimes if I say the word solid, you're like, oh, I know it's closed. But we have to be a little creative with this, because that's a solid line. That's closed, like it's shaded in. How do I show an open line? How could I change that line to show that it's open? We got to put arrows on the line because it's going to keep going on and on. Not make it as dark. Close. We're going to put some spaces in it. So we're going to make it like a dashed line. So I call this dashed, if you want to write dashed next to it if you're like, what the heck? And sometimes when I say dashed, it doesn't come out, it comes out weird. So, dashed. Alright, so as we go today, that's going to be one of the big differences. And then another big difference is how we shade it in. When we were shading in number lines, remember we shaded to the left or to the right? But a graph goes like in all directions. There's a left, a right, an up, and a down. So the way we shade it in is going to look a little different as well. Alright, you're going to be getting some graphs. If you get more than 2 graphs, that means you're going to share with your partner. So cut them apart, share with your partner. You're going to glue in both your graphs if you have room on the same page. And you're going to glue them in right over here. Okay? So I'm going to pass out some graphs. If you get more than 1 graph sheet, that means that you should cut it apart and share with your partner. And then Andrea, I got some right there already. want to use those ones? You guys have that part? You got this part chair. You know you're going to do your notes today? Should I hand you graphs or no? Pass it? We're just use it. Nemo saying, no thank you. No learning today for me. Hi. Well, that's how you're going to do your notes today? Alright, so go ahead and cut those apart. Everyone should get 2. You might need to trim it down so that you can fit it into 1 page. And then you're gluing them. But you want these are going to do your notes or not? You're going to do your notes with these 2? You can do them out to the back. Alright, so go ahead and glue those in, share those glue sticks. If you got more than just the 2 that I handed you, cut them apart so you can share with your table, because I didn't get a chance to cut them out earlier. So as you guys are high schoolers, you guys can share. How exciting. Alright, and then I'm just gluing them in one on top of the other. I'm going to show my work over here. If you don't have room to glue both in on your paper, you might just need to glue the next one in on the next page. It'd be better to just separate them out rather than squish them together. Perfect. After you get that done, you are going to take out a colored pencil. I'm going to use an orange colored pencil. You can also use a highlighter today if you'd like to. And if you can find those rulers in your bin, find a ruler and something to color with, either a colored pencil or a highlighter. Alright, give you about 1 more minute. I'm going to come around and collect scraps of paper. Alright, about 45 seconds. So get those glued in. Ready to get started. If you don't have any of those rulers, I had a lot that were taken by, I hope, accident. Possibly not on accident, but either way, some of them are taken. So if you don't have this, you can always use the side of your notebook, side of your phone, something. Alright, we have 2 examples. The first example is going to be a little bit longer than the second, because the first one we're going to do a little bit more like exploring and figuring it out. The second one, we're going to just kind of just do it. You know what I'm saying? Cool. All right, number 1. We have y is greater than or equal to 1/2 x minus 4. So there's actually quite a few things that we can tell about this line before we even graph it. The first thing that we can tell, or the things that we need to tell first, like what's the slope and the y-intercept, because we need to know that in order to graph. So what is my slope and what is my y-intercept? If you need to, you can write above it that mx plus b. My slope is 1/2, and my y-intercept is -4. All right, before I graph it, I'm going to think a little bit about that inequality. So that inequality is a greater than or equal to. So is that going to be an open or a closed border? Good, closed. Why? Good, it has that equal to. And when I graph, what does a closed line look like? You guys don't put like t-shirts and socks on your clothesline? Miss Morale, you're so funny. Pranks. All right. So it's closed. Good, it was solid. All right, when we graph it, we're going to now go to that graph. We're going to come back to this in just a second. Where do we start at our M or our y-intercept? Y-intercept. So remember, we have our x-axis and we have our y-axis. Our y-intercept is -4. So am I going to go left, right, up, or down 4? Thank you. Where would that -4 be? Down 4. Good. So from that origin, we're going to go down 1, 2, 3, 4. Now from that point, we're going to do our slope, our m. If you need to, you can write m as your rise over your run, like we did back in B4. So what is my rise? 1. And what is my run? 2. So 1 tells me to go which direction? Up 1. And then the 2 tells me to go right 2. Good. So from that point we already made, we're going to go up 1 over 1, 2. Okay, from that point we go up 1 over 1, 2. We can even do it one more time. That one wasn't very good. I wasn't paying attention. Sorry. Up 1 over 1, 2. So those of you that maybe are looking to retake the Unit B test or the Unit C test, or maybe you haven't taken them yet and you're like, oh crap, I got to take those before the end of the trimester. This is a good review for you to figure out how to do that. Okay? So we have those points. Now we're going to use our line. This line is just like our normal line. It's just a normal solid line. So we can just use that ruler. If you don't like rulers and you want to try and freehand it, I guess you can do that. So it's a closed line, which means it's a normal solid line, meaning it's okay for it to be equal. I'm going to come back to this in just a second, so if you don't freak out, just breathe. Okay, so on this one, we had that closed circle. Is that all we did was just the circle? No, what else did we have to do? Yeah, we had to decide if it was left or right. But in coordinate plane, we have like everywhere. There's an up, there's a left, a right, an up, and a down. So we have to figure out where are we going to shade. Okay, and what that does is it comes back to this inequality. This is a greater than or equal to, and I want y's that are greater than or equal to. So if I look at my y-axis, are greater than y's going to be above that y-intercept, or is greater than going to be below the y-intercept? Yeah, above, because this is -4. What's greater than -4? -3 or 2, like all of these up here. So because it's a greater than or equal to, we are going to shade above the y-intercept. And that's where I'm going to use my color. So with this y-intercept, this was -4. I want to go above, so I want to do like -3, -2. And then what actually happens is it's this whole part that's above this line then. We're shading in that whole section. I would use a colored pencil because we are going to use our pencil to do some stuff there. If you're using your pencil, do it really, really light because we are going to write some things over in the spot. All right, we're going to mark some points on this graph. The first point we're going to mark is this point here that we already have. That's point A. All right, we're going to go from the origin. We're going to go right 2, up 1. And that's going to be point B. And then point C, I'm going to go right 5. And then I'm going to go down 4. And that's going to be point C. So remember when we have solutions, solutions means it makes the inequality work. It's a good thing. It works. Okay? So if I take these points, some of them should work and some of them aren't going to work. Okay? So let's see which ones work, which ones don't, and double check our work here and see if it makes sense. So I'm going to start with A. I'm going to try and show kind of all my work over here, so I'm going to write all the way to the edge here. So I'm going to start with point A. What is my X and my Y for point A? How would I get to that point from the origin? Good. I go right 2, positive 2, down 3, so negative 3. So 2, negative 3. What's my B? X first. Yep, X is 2, then up 1. And then my C? Good, we went right 5, down 4. All right, so what we're going to do is we're going to go back to our original inequality. This y is greater than or equal to 1/2 x minus 4. And we're going to plug in that y and x and see if we get something that's true. So this starts with y. What's my y from point A? Negative 3 is greater than or equal, and it goes 1/2 times x. So 1/2 times our x. What is our x? Negative 3 was our y. 2. That's okay. Minus 4. I think you worked ahead probably. That's okay. Alright, so on this left side, this negative 3 is going to stay the same. Greater than or equal. On the right side, we're actually going to find that answer. And you can either do it in your head, you could use a scratch paper, you could use a calculator. My brain's not working very well today. I have a really bad headache and I'm really hot, so I'm going to just use my calculator because that sounds easy. So I'm going to do 1/2, oops, not 12, parenthesis 2, so times 2, minus 4. And we get negative 3. Ray's already answering a question that I didn't even ask. He knows what I'm thinking. Is that true or is that false? Is negative 3 greater than or equal to negative 3? Yep, it works. So I'm going to put a little star next to A saying, yep, it worked. I'm going to do that on my graph. Yep. You can put a smiley face there or a little heart being like, woo, we love A. All right, B. B is in our shaded region. Should B work? Yes. The shaded part is the part that we're saying, yes, it's good. So it should work. Let's just double check our work. We're going to start with our y. What is our y? 1 is greater than or equal to 1/2 x. What is our x? 2 minus 4. So we don't need to do any solving. We're just putting it in our calculator, that 1/2 times 2 minus 4. Oh, wait, we already did that. We don't need to do that again. What's 1/2 times 2 minus 4? We got negative 3 earlier, right? It's the same thing. So, is 1 greater than or equal to negative 3? Yep. Put a little star, smiley face, a heart, something. Says, yep, that one's good. All right, C is in the not shaded region. So should C work? No. Let's double check. What is our Y? Negative 4 is greater than or equal to, it goes 1/2 x. What's our x? 5 minus 4. I'm going a little in my graph. Whoops. So negative 4 is greater than or equal 1/2 times 5 minus 4. We get negative 1.5. Or negative 1.5. However you want to think of that. I'm going to think of it as a decimal. Is negative 4 a bigger number than negative 1.5? No, remember, because negative 4 is actually more negative. And when we get more negative, does that mean a bigger number? No, more negative actually means it's a smaller number. So does this one work? Nope. So I'm going to put an X there. I'm going to very lightly cross out the C here so that I can still see it was there. I can visually see that C is there. But I want to cross it out saying, nope, it doesn't work. All right, number 2, we're going to go way faster through this. We're not going to take time to do this last part. We'll just talk a little bit about it. We won't go through and plug it in and see what works and what doesn't work because you guys get that idea, kind of. Maybe you don't. I don't know. We're going to pretend. All right, number 2. Number 2, we have y is less than negative 5x plus 3. So like I said earlier, there's a lot of things that we can tell from that inequality before we even go to that graph. On your practice today, or on your quick check, the first 2 questions are going to be a lot of interpreting what is here. What do we have? How can I do that on the graph? Not necessarily about looking at the graph almost. Well, you're going to look at the graph. That was a lie. All right. What is our M? And our B? 3. All right, now I'm going to take a look at my inequality. My inequality is a less than. Excuse me. Is less than going to be an open or a closed line? Open. And how do I show an open line? Dashed. Smooth. So it's a dashed line. All right, now when I think of y being a less than, do I want to think of numbers that are less than are going to be above or numbers less than are below? Yeah, unfortunately when you're smaller, when you're shorter, you're below other people. So less than means we're going to go below. So this one we're going to shade below. Have a good day. So we're going to shade below the y-intercept. And that's even without graphing it. We can just look at that inequality. So some of your work today, you're going to be looking at just this information and saying what you see. And some of it you're going to match with the graph. So now that we know it's open, we're shading below. We're going to find that graph that has that open dashed line shading below. Okay? All right, but we're actually going to graph this one. So where do I start? Good, we start at that y-intercept. So right, left, up, down. Where's 3 go? Up 3. And then I'm going to do my rise and my run. So again, if you're looking to retake your Unit B or Unit C test, this is going to help you with that. So we start on that B, that y-intercept. What is my rise and my run? How did you know it was over 1? Yeah, there's nothing there, so when we see nothing there, we can always put a 1. So does negative 5 tell us to go up or down? Down 5, but then it's a positive 1, so are we going to go left or right? Right. Positives are to the right. So from this point, we're going to go down 5. 1, 2, 3, 4, 5. Over 1. And then we're going to do it one more time. Down 5. Oh, we ran out of space, but that's okay. We can just estimate about where it is. We're at that point in our graphing. We can make a good guess about where that is. All right, but when we draw the line this time, what do we want our line to look like? Dashed. So there's a couple ways to do that. One way to do that is by picking up your pencil. That's my personal preference. I do a little thing, pick up my pencil. A little thing, pick up my pencil. Okay, you want to leave spaces between your dashes. Some people like to actually do a solid line, and then they use their eraser and go back and erase little spots. I think that sometimes those people forget that they were doing a dash line, so they're just like fixing their mistake. But either way works. We're going to get that dash line. We have to see that it's open, that there's spaces there. All right, and then I'm going to shade. This one's a little bit harder to think about because when I look at that line, there's not really a above part of the line and a below part of the line. So that's why when we think below, we want to go to that y-intercept because it's y is less than. So when I go to that y-intercept on that y-axis, our numbers that are less than, is it going to be the 4, 5, 6? Or are numbers less than going to be 2, 1, 0? 2, 1, 0. So I'm going to go below like that. And then that kind of gives me a indicator that I'm going to go below on that whole line like that. So this is the below part. And then we shade in that whole side of that graph. All right, let's just pick a couple points, because this one there's a little bit thing that's a little different. All right, we want to let's pick a point that we know is going to work. So a point in the orange, or in the shaded region. Who's got a point for me somewhere over here? -2, 4. So -2, 4 is right here. Do we know that that point, let's call it H, is that point going to work? Yes. We're saying, yep, that one's good to go. We could test it out like we did last problem. That's a lot of work. We're not going to do that this time. Let's pick a point that we know for sure is not going to work. So a point in the not shaded region. 4, +2? Okay, you want to stay in the positives? You can do that. 4, 2. Let's name that G. If you named it something else, that's okay. You name it whatever you want. All right. Is that point going to work? No. So I'm going to do that light X over it so I see that it's there, but I'm saying to myself, nope, doesn't work. All right, now here's the deal. If I pick a point that's on the line this time, let's pick this one down here. Let's call that point J. Last time, when we picked a point on the line, did it work? Yeah, point A worked. But when I did put in point A, what kind of a thing came out? It's an equal to. Yeah. Anytime we pick a point on the line, it's going to be an equal to thing. This time it was okay because we had that equal to option. If I get an equal to in this inequality, like 2 is less than 2, does it work? No. So because it's dashed this time, it's an open line, the line doesn't work. J is not a solution. Okay? But back in that last problem, A works because it's a closed line. It has that equal to option. Does that make kind of sense? It's a little abstract.